Hey everyone, so in Python, it's pretty easy to get your code to follow plan A. But what happens when things just don't go according to plan? Well, that's exactly what we're diving into today, giving our programs an essential plan B using the else statement.
Seriously, think about this for a second. Right now, your code probably knows how to handle one specific thing, right? If some condition is true, it does its job. But what happens if that condition is false? Nothing. It just stops, it stays quiet, and that, my friends, is a pretty big limitation. But don't worry, we are absolutely going to fix that right now.
You know, in real life, we all have a plan B, don't we? If your favorite coffee shop is packed, you just go to the one down the street. It's second nature. Well, guess what? Your code needs that exact same flexibility. It has to know what to do in that otherwise situation for all those moments when the first if condition just isn't true.
And honestly, this is the thing that really separates a basic, simple script from a truly smart program. An if statement? That's only half the story. It's just one side of the coin. If you want to build code that can actually react to the real world, you've got to define that otherwise path. Okay, to make this super clear and not just abstract code talk, let's use a simple, real-world example. Picture a high-tech door lock. It's got two and only two possible outcomes. The logic here is dead simple. First path, if you have the key, boom, the door opens. That's our true condition. Second path, else, and this is the key part, in literally every other situation, the door stays locked and maybe an alarm goes off. See, there's a clear, defined action for both possibilities.
All right, so how do we take that real-world logic and actually write it in Python? You're going to love this, because it's pretty much a perfect one-to-one match.
So let's get a nice, clean definition down. The else statement is exactly that. It's your code's plan B. Think of it as the catch-all block. It's the code that runs automatically whenever that first if condition turns out to be false. It's your default action.
And check this out. You can see the parallel perfectly here. On the right, in the Python code, we've got a variable hasKey that we've set to false. The if statement checks, hey, is hasKey equal to true? Well, no, it isn't. So Python completely skips the welcome home part and jumps straight down to the else block, running that code instead. And that's why it prints access denied, calling security.
Okay, so using else is actually super easy, but there are three simple rules you just can't break. They're non-negotiable parts of the syntax. Let's walk through them one by one.
All right, rule number one, the colon. Just like with an if statement, the word else has to end with a colon. That little dot is Python's signal saying, okay, get ready, here comes the code for this part. Rule two, and this is a big one, else never gets its own condition. You don't ask it another question. Why? Because its whole job is to be the catch-all for when the if condition fails. And finally, rule number three, indentation is king. You know this. Any code that belongs to the else block must be indented underneath it. No exceptions.
Okay, that's the concept, and those are the rules. Pretty straightforward, right? So let's put what you've just learned to a quick little test.
So here's the setup. We have a variable called temperature, and we've set it to 35. Then, the code checks a simple condition. Is that temperature greater than 30? If it is, it'll print one thing. If not, well, it'll print something else.
So go ahead, take a look at the code. Based on that temperature value of 35, which chunk of code do you think is going to run? The if part or the else part? What's the final message going to be?
And the answer is, it's hot, turn on the AC. If you got that, awesome job. It's because 35 is in fact greater than 30. So that if condition is true, its code runs, and the else block, Python doesn't even look at it. It's completely ignored.
You know, getting this concept down really unlocks a brand new superpower for your coding. This is a huge step forward. You're moving way beyond simple one-track mind scripts now.
So what's the big takeaway here? It's that your programs no longer have to have a single track mind. Your code isn't stuck on just one path anymore. It can now look at a situation, evaluate a condition, and choose between two completely different routes. It can handle A or B, true or false, yes or no.
And that leads us to a really interesting final question. Being able to handle two outcomes is a massive leap forward for sure. But what happens when you need to handle three possibilities? Or four? Or more? What if the traffic light isn't just green or red? What about yellow? Well, figuring that out, that's the very next step on our code.